Systems of linear equations are often used in mathematics to describe two events and the relationships between them. The most famous probably being about two trains heading to some destination, and we want to know who's going to get there first or when do they cross. But basically, systems are just used to measure and compare two different events, usually over time. Before we start actually graphing linear systems, let's just go through some vocabulary and some basics that you need to know about systems. Take a look through the vocabulary list and select continue when you're ready to go. All right, let's go through our first definition here. A system of linear equations consists of two or more linear equations that have the same variables. Okay, so that's the technical term. All it really means is we've got two equations that have at least two variables, and each equation has the same variables. So for example, equation 1 will have an x and a y, then equation 2 must also have x and y. A solution of a linear system with two variables is an ordered pair that satisfies both equations in the system. So for example, if we used the variables x and y, then my solution would be the ordered pair xy. For this next section on these three cases, we'll be drawing some straight lines, so you will want to grab a ruler or some kind of cardstock straight edge so that you can draw your lines very straight. I'll give you a moment to do that. Don't draw this yet, but I'm going to start with two lines, and we're going to talk about all the different ways we can arrange them. And it turns out with two lines, there's three different things that could happen. The first thing is kind of what you see right here. I've got two parallel lines, but what I'm going to do is move around this blue line and see what else I could do. So now you can see that the blue line and the red line intersect at one place. And as I move these lines around, I really can't get them to intersect at more than one location. So when I'm talking about lines, not any kind of curved function, then two lines can only intersect at one location at a time. In other words, they can only cross each other at one place at a time. Our other option, of course, is that they are parallel, so that's case 2. Case 3 is that they are actually right on top of each other. So those are the three things we're going to draw right here. Case 1, you're going to draw two lines that intersect. It doesn't matter where you have them intersect, but you can see that there is one solution for this one. We call this an independent system, and it's independent because each line kind of does its own thing. They're independent of each other. The second kind is going to be our parallel lines. So anywhere on your graph, just draw in two parallel lines for case 2. The number of solutions will be none, and the type is called inconsistent. This is because they have nothing in common, so we just call that inconsistent. And I realized mine don't look perfectly parallel, so let me fix that. There we go. I think that looks a little bit better. Those two lines are not going to cross at any point off that graph. All right, and of course, case 3 is where we have two lines actually on top of each other. This might be a little bit tougher for you to draw, but if you just make your line super thick, or if you have two different colored pencils, highlighters, markers, two different colors that you could drop onto each other, what we can see here is that every single point on those two lines they have in common. So this one has an infinite number of solutions. And we call this a dependent system because each solution, every single point, is completely dependent on the other equation. Every part of that graph depends on what the first graph is doing. That's just a rundown of the basics of a system of equations. And we're going to actually take a look at how to do some of these problems in the next lesson.